Next, let's move on to payment coins and mediums of exchange. So a medium of exchange is an instrument used to enable the sale, purchase, and trade of goods between parties. Here's a list of projects that aim to focus solely on payment transactions. Litecoin LTC, Stellar Lumen XLM, Ripple XRP, Monero XMR, and USD Coin. Now, within the payment coins category is a subcategory known as stablecoins. Stablecoins are digital assets created to imitate the value of fiat currencies such as the US dollar or the euro. They allow users to quickly and cheaply transfer funds around the world while maintaining a stable value. Most stablecoins are backed by a 1-to-1 ratio of dollar to coin. Projects such as Tether have collateral that backs their coins in the form of fiat, which is dollars, other cryptos, or other commodities stored in the reserves. This could be in the form of gold or silver. Some examples of popular stablecoins are Tether, USDT, USD Coin, USDC, Binance USD, and DAI. So here's a visual representation of this relationship and this ratio between Tether, USDT, and US dollar, where essentially Tether will essentially constantly maintain a 1-to-1 ratio, essentially maintaining a balance and equivalency to a dollar. Next up, let's talk about privacy coins. Cryptocurrencies are mostly pseudonymous, meaning that although true names and locations are not recorded into the blockchain, wallet addresses and transaction IDs are in fact recorded. So while your name and your address and your social security number is not necessarily used and recorded when using a Bitcoin transaction, your wallet address and your transaction history is made available for everyone to see. Theoretically, one could search through a history of transactions and attempt to associate a user with a mix of wallet addresses and transaction histories. Privacy coins aim to eliminate this potential flaw by masking transaction information. Some examples of privacy coins are Monero, Zcash, and Dash. Here's just an example of their logos. We have Monero or XMR here, Zcash in the center, and Dash. So let's dive into how XMR works and how it compares to a standard Bitcoin transaction. So looking at the left side, here are some examples of traditional Bitcoin transactions in the Bitcoin ledger, where we have address A is sending 20 Bitcoin to address F, address B is sending 8 Bitcoin to address G, and address C is sending 11 Bitcoin to address T. Now, while we can't necessarily associate names and persons or places with these Bitcoin addresses, we can start to associate addresses according to their transaction history or maybe accumulation, and we could start to pinpoint, hey, address F has a lot of Bitcoin. This is their 5th Bitcoin transaction that they've gotten 20 Bitcoin. Now, XMR essentially scrambles this information, where each address, sender, and receiver is masked along with the actual amounts of XMR sent. So each transaction is essentially masked and scrambled and can't be tracked as typical, such as on a Bitcoin blockchain explorer. Now, one of the major aspects of blockchain technology and a blockchain ecosystem is the use of a blockchain oracle. Oracles are third-party services that send information to smart contracts from external sources. Blockchain networks on their own can only source information from data on the network itself. Oracles act as a relay where off-chain information can be supplied to various blockchain networks. Some examples of oracles are Chainlink, UMA, and the BAN protocol. Now, arguably, the most popular blockchain oracle is Chainlink. It's by far the most popular and the most used. Here's how Chainlink works. Essentially, here are just various data sources. This could be sports information, weather, maybe information from traditional stock markets such as the New York Stock Exchange, etc. And here is a decentralized blockchain such as maybe Bitcoin or Ethereum. Now, essentially, this information here from the data sources can't be sourced to the blockchain without a third party. There's no way of programs and applications running on Ethereum to directly interact with information that's stored on the New York Stock Exchange. Chainlink essentially acts as a middleman where it can source information from real-life events or other sources, maybe even other blockchains, and relay this information to the designated blockchain. And from there, that information is transmitted through the various nodes operating on the network. And here are examples of the various types of information. This could be information, like we said before, from the New York Stock Exchange, or maybe from a Bloomberg terminal, possibly from specific banks such as Wells Fargo, Citibank, and also information from SWIFT, which is what the banks use to transfer money between their branches and from bank to bank. We also see retail payments in the form of MasterCard, Visa payments, and PayPal. Information from other blockchains. So Ethereum and Bitcoin can't necessarily communicate with one another. So if there's a transaction or if there's something going on or information on the Bitcoin network, Ethereum needs a third party to source that information. That's where Chainlink comes in. Other sources could be web APIs, other events, and other backend systems. Essentially, this information is transferred from the data provider through the Oracle network into the designated blockchain. This could be information, this could be on Ethereum. These could all be different nodes. And as a response, these nodes can transmit information back to Chainlink, which can then send information back out to its data provider, such as any of the various sources mentioned before, other blockchains, other traditional financial structures, and more. Now, Chainlink can also track information from various exchanges. And this is highly useful because each exchange essentially acts as an ecosystem where, let's say, information from Coinbase, prices from Coinbase, Binance, Kraken, and any other exchange can be sourced and essentially compiled in one trusted location. And the smart contracts operating on Ethereum can use this information to comfortably and confidently acquire information to source possible price increases or price valuations or volume data or any other metric.